So now we're actually going to use the power series to help us estimate this integral of tangent inverse x over 2 from 0 to a 0.5. And in the previous podcast, number 89, we found that this is the series for tangent inverse. So we can use that. And since it says estimate, we could just use maybe 3 or 4 terms of it. So if you start with n equals 0 and substitute a 0 for all of these n's, then first of all, there would be negative 1 to the 0, so that's just 1. And then there would be x is raised to the 1 power once you substitute a 0 in there. And on the bottom, it's going to be 2 raised to a 1 power. And then this part is just going to be a 1. So actually, my fraction bar didn't need to be so big. It turns out that the first term is just x over 2. All right, then go back to all those purple n's and substitute a 1. So we'll have negative 1 to the 1, so that's going to make it negative. And then if you substitute a 1 for this n, that's going to create 2 plus 1, so that's x cubed. And then on the bottom, this is going to be 2 cubed, so that's 8. And then when you substitute a 1 for this last little n right here, that's going to create a 3. And next, if you substitute that n is a 2, so go to all those purple n's, and if you substitute a 2, negative 1 squared is positive 1, so it's going to be positive. And when you substitute a 2 in here, that's going to be x to the 5th. And then on the bottom, it's going to be 2 raised to the 5th, which is 2, 2, 2, 2, 2. So that's 4, 4 times 2, so that's 32. And then when you substitute a 2 right here, that's going to be 5. And for fun, let's just do one more. So the next one would be, so on the top I can see the pattern. So the next one is going to be x to the 7th. And then when you substitute the 3, this is going to be 2 to the 7th. And then times 7. Okay, so that should be enough to estimate it. Now it says to integrate this. So to integrate tangent inverse would take a lot of work. So integrate this from 0 to a 0.5. And then this should be turned into an approximation since we're only using 4 terms. And then I do need to say dx since x is our variable. So then just go term to term and integrate. So the first one would be x squared over 2. And because there was already a 2 down there, then it's x squared over 4. And next is going to be x to the 4 over 4 times an 8 times a 3. And then x to the 5 over 5. So if you put an extra 5 down there, that's going to be 32 times 25. And then, oh, hold on, I almost made a mistake. Because I forgot that 5 plus 1 is 6. So add 1 to the exponent, Greg. Oh yeah, that's 6. And then if you put an extra 6 down in the denominator, that'll be a 30. And then minus x to the 8 over 8. So that'll be 2 to the 7. And then 7 times 8 is 56. And then evaluate that from 0 to a 0.5. And then our work is cut in half because when you substitute 0, it's going to contribute 0. So basically we just need to know how much is the 0.5 squared over 4, and then a 0.5 to the 4th over whatever 4 times 8 times 3 is. And then a 0.5 to the 6th over 32 times 30. and then a 0.5 to the 8th over 2 to the 7 times 56. And then what does all of that equal? So calculating this quickly in my head, just kidding, I have to write it down before I go to the calculator. Okay, so now go over to the calculator, and we have 0.5 is squared divided by a 4. Oh, the next one is minus, and then a 0.5 is raised to the 4th, and then that is divided by 4 times 8 times 3. And then plus a 0.5 raised to the 6th, and then that is divided by a 32 times a 30, and then minus a 0.5 is raised to the 8th, and then that one is divided by 2 raised to the 7th times 56. There we go. So it's a 0.0619. So then I also want to graph it and see if that is correct. 0.619. So go to y equals, and then there's the tangent inverse. Take a look at the graph, and then calculate. And as you can see, I was practicing before you got here. Integrate from 0 to a 0.5, and it says that the answer is a 0.619. So I can't really highlight on this screen right now, but on that little calculate part, it says 0.0619. So we got a pretty good estimate. So finally, we got 0.0619. And then for extra fun, I'm just wondering, did we even have to use that many terms? So what if I go back, get this back, and let's say I just drop off this last term, and I only use the, if I can delete all these guys, almost there, almost there, almost there, almost, there we go. So what if I only use those terms? So the first 3 terms, it's the same. So we don't even have to use that many terms to get a good estimate for the integral.